All right, I'm going to do a very simple demonstration that I did in class today. It's Tuesday, September 14th. Excuse my voice, as you know that I've been sick. All right, so we have our pie, all right, baking, all right, container, and I'm going to show you a very simple demonstration for what we've been talking about in class, which was kind of the formation of our solar system when we were talking about the nebula hypothesis or nebula theory. So today I'm going to be using Quaker oats, all right, for one part of the simulation, and the other one's going to be some Lipton loose tea. So what you're going to see is I'm just going to take some Quaker oats, and I'm going to randomly put them, all right into this water. All right. And I want you to pay attention to where you see the oats are distributed or where they are. I'm just going to kind of zoom in and show you some different areas. All right, I'm going to reach across here and I'm going to grab some tea. All right, and you're going to see I'm just going to sprinkle the tea wherever it may fall. All right, so I've got this nice little gross soup I've got going on here. I'll even just add some oats in for some extra, fun. All right, so you take a look. You can see if there's any patterns, where it is. I'm going to stand back. Just going to put my spoon around the edge. And I'm just going to start to stir. When we talked about our nebula theory, our nebula hypothesis, that has gravity and it pulled into the center, it would start a rotation. And all of the rotation was going in the same direction. So right now you see everything is spinning in the same direction. And you may notice some changes to what you're seeing inside the container. I'm going to try not to move. All right, and the question is do you see any patterns have formed or any changes? And right away you should see a very distinct change. Now what happened, I'm going to use a pointing tool from our pumpkin carving kit. All right, as you'll notice that all of the oats have now pulled toward the center. So there's oats in the center. You'll also see some of the tea down there. There is some tea that now has also mixed in with the oats. All right, and what this is showing you is that as our nebula, all right, or our solar system was forming, all right, the matter pulled into the center. So look at the majority of all of our matter here in our pie dish is in the center. So I asked the students in class, I said, what's in the center of our universe? Give yourself a second to think about that. What's in the center of our universe? And it's the sun. Look at how much of the material from the pie container has moved all the way into the center. All right, so that would be equivalent to our sun. Everything that's in the middle. So then we're going to take a look at some outlying pieces. So ask yourself the question in this demonstration, which is heavier? Is it the oats or is it the tea leaves? And I'm hoping you're saying to yourselves, it's the oats. All right, so I'm going to zoom in a little bit. And maybe there are some oats that didn't fully attach to our sun. So like that middle section. I'm going to say like right here, I'm going to point to an oat. That one oat, didn't attach to our center sun. All right, I'm going to come up here. Look, I've got another oat right there. That didn't all the way attach to the center. My bad pointer. All right, I'm scanning around these peripheral areas. Where is there an oat? All right, it's a little cloudy. I think my water was a little warm. All right, but I think I see an oat. Let me see if I can point to it. There it is. Let me see that oat right there. So that oat didn't attach all the way to the sun. What would those oats be? Those oats are the equivalent to a planet, all right? But it would be a heavier planet. I'm going to hit pause for a second. So I'm resuming my recording. All right, so now what we're going to do is I'm going to use this analogy and I'm going to bring it over to a drawing. So if we spun everything, which we did, and the oats all came to the center, there's the example of the sun. All right, so you can see in my drawing over here, the sun. So what are these inner planets? These inner planets are the rocky or the heavy material, all right, that was still pulling toward the center but didn't all the way make it. So maybe it's, an example would be like that one oat, didn't fully, attach or come all the way into the center. Maybe we have that outlying oat. Maybe we've got something up here that's an outlier. All right, but you'll also notice with the tea leaves, all right, that they're not sprinkled all over the place. Somebody in class said at the start they looked like just one ant all over the place, so like hundreds of ants. But now it looks like they're groups of ants. So I've got like a group or a cluster. You can kind of see how they've kind of joined together in different little sections. All right, so what is that? That is the sun being the center of our pie. All right, everything pulled to the center. Anything that's kind of right around the sun, that's going to be that heavier material that just didn't all the way go inside. So that's going to be our metals and our rocks, our heavy inner planets. So we have Mercury, Earth, Venus, Mars. All right, we have all the inner planets that are, heavy material, as opposed to our gas giants out here, our lighter planets. And we think of like Jupiter, all right, Saturn, Uranus, Neptune. That in our demonstration is seen here by the tea leaves that didn't go all the way into the center. So where did 99.8% of all of our stuff go? You're probably, if you weren't in class, like, why is she saying 99.8%? Because our sun, back over to here, all right, is going to be 99.8% of all matter, all right, in our solar system is going right into the sun. Everything else, all out here, all right, this is just 0.2%. It's really quite insignificant, even though we live on planet Earth. All right, so that's what we did in class today, just showing that demonstration how everything would have pulled to the center, all right, and all the oats really, even though they started everywhere, they really came together and they formed one solid mass.